Right now, as you're watching this, Earth's magnetic North Pole is racing across the Arctic at 55 kilometers per year. That's faster than you drive on a highway, and scientists, they're genuinely concerned about where it's headed. Picture this. You wake up tomorrow morning, grab your phone, and every GPS on the planet is off by hundreds of miles. Your compass points in a completely wrong direction. Airlines are grounded, ships are lost at sea. Not because of some cyber attack or technological failure, but because the planet itself just rewired its magnetic personality overnight. Sound impossible? It's not. It's happened before. Hundreds of times, actually. And if some scientists are right, we might be living through the early stages of it happening again. Today, we're diving deep into one of Earth's most spectacular and terrifying phenomena: magnetic pole reversals. We're talking about the invisible shield that protects all life on this planet suddenly weakening, twisting, and potentially flipping upside down. And unlike earthquakes or volcanic eruptions, this isn't something that happens in one spot. When Earth's magnetic field decides to flip, the entire planet feels it. By the end of this video, you'll understand why your compass works in the first place, what's really causing that North Pole to sprint towards Siberia, and what actually happens during one of these flips. Spoiler alert, it's way stranger than you think. Let's start with something most people never think about. That compass on your phone, the one that tells you which direction you're facing, it's not pointing at the North Pole, not the geographic one you see on maps anyway. It's pointing at something else entirely, something invisible, something alive in a weird way, something that moves. Deep beneath your feet, about 3,000 kilometers down, there's an ocean, not water, iron, liquid iron, hotter than the surface of the sun, swirling and churning in an endless dance that's been going on for billions of years. And this isn't just some interesting geology fact. This molten ocean is the reason you're alive right now. As this liquid metal flows, it creates electric currents, massive ones. And those currents generate Earth's magnetic field, an invisible bubble that surrounds our entire planet. Without it, solar wind would strip away our atmosphere, cosmic radiation would bombard the surface, life as we know it wouldn't exist. But here's what's wild. This protective shield isn't stable. It's not constant. It shifts, it weakens, and every few 100,000 years, it completely reverses direction. North becomes south, south becomes north. The entire magnetic field of Earth flips like a cosmic light switch. And we're overdue for the next one.
So how do we know any of this actually happened? I mean, there weren't exactly scientists around with clipboards 780,000 years ago taking notes during the last full reversal. The answer is hiding in plain sight, locked inside the rocks beneath our feet. Here's how it works. When a volcano erupts and lava pours out, that molten rock is loaded with tiny iron particles. And as that lava cools and solidifies, those particles do something remarkable. They act like millions of microscopic compass needles, aligning themselves with Earth's magnetic field at that exact moment in time. Then they freeze in place, creating a permanent snapshot of which direction was magnetic north when that rock formed. Scientists call this paleomagnetism. It's like Earth's magnetic diary written in stone. And when researchers started examining volcanic rocks of different ages from all over the world, they found something absolutely mind-blowing. The magnetic signatures didn't match. Rocks from certain time periods pointed north, but rocks from other periods pointed south. Not just slightly off, completely reversed, 180 degrees opposite. And it wasn't just one or two weird anomalies, it was everywhere. The ocean floor, volcanic islands, ancient lava flows on every continent. The evidence was undeniable. Earth's magnetic poles have flipped hundreds of times throughout history. The last major reversal happened about 780,000 years ago, during an event scientists call the Brunhes-Matuyama reversal. Before that, another flip about 2.6 million years ago. And before that, another and another. Sometimes the poles flip every few 100,000 years. Sometimes it takes 1,000,000 years or more. There's no regular schedule, no predictable pattern. Earth's magnetic field operates on its own chaotic timeline. But here's what really keeps scientists up at night. In between these full reversals, there have been events called excursions. Temporary weakening, where the poles start to wander dramatically, sometimes even attempting to flip before snapping back. The last major excursion happened just 42,000 years ago. That's practically yesterday in geological terms. Now, you might be thinking a pole flip sounds like a sudden event, like someone throws a switch and boom, everything reverses overnight. But reality is far stranger and way more chaotic. A full reversal takes time. We're talking anywhere from 1,000 to 10,000 years, though the most intense changes might happen over just a few centuries. And during that transition period, things get weird, really weird. The magnetic field doesn't just smoothly rotate from one orientation to another, it weakens dramatically, losing up to 90% of its strength in some areas. It fragments, creating multiple north and south poles at the same time. Sometimes 6 or 8 poles scattered across the planet. The field becomes unstable, jerking around erratically before finally settling into its new, reversed configuration. Imagine trying to use a compass during this chaos. Some days it points north, other days it points east. Some days it just spins uselessly because the field is too weak or confused to give a clear signal. For any creature or technology relying on magnetic navigation, it would be absolute mayhem. And here's the kicker. Scientists think we might already be in the early stages of something like this right now.
Remember how I said the North Magnetic Pole is currently racing across the Arctic? Let's talk about that. For most of recorded history, the magnetic North Pole hung out near northern Canada, wandering slowly but predictably. Scientists could track it, map it, update navigation systems accordingly. No big deal. Then something changed. Starting in the 1990s, the pole began accelerating dramatically. It went from drifting about 15 kilometers per year to 55 kilometers per year. That's not a subtle increase. That's the magnetic pole suddenly deciding it has somewhere urgent to be. And where is it headed? Straight towards Siberia. This has never happened this fast in the modern era. It's moving so quickly that scientists have had to update the world magnetic model, the system that GPS and navigation rely on, more frequently than ever before. They used to update it every 5 years. In 2019, they had to issue an emergency early update because the pole had moved so far off the predictions that navigation systems were becoming noticeably inaccurate. But wait, it gets weirder. There's a region over South America and the southern Atlantic Ocean where Earth's magnetic field is bizarrely weak. Scientists call it the South Atlantic Anomaly, and it's been growing. In this zone, the magnetic field is about 30% weaker than it should be, and it's expanding year by year. This isn't just an academic curiosity. Satellites passing through this region get hit with higher doses of radiation. The International Space Station's computers have been known to glitch when passing through it. Some satellites have even been temporarily knocked offline. It's like Earth's protective shield has a massive hole punched in it right there. And here's the question nobody can definitively answer. Is this the beginning of a full pole reversal, or is it just a temporary excursion that'll correct itself in a few thousand years? Some scientists look at the rapid pole movement and the weakening field and see warning signs. Others say Earth's magnetic field has always been chaotic, and this is just normal geological weirdness. Here's what we know for certain. Earth's magnetic field has weakened by about 9% over the past 200 years. That might not sound like much, but in geological terms, that's a significant drop happening fast. Some regions have seen drops of up to 30%. The field's intensity has been decreasing at an accelerating rate. Now, does this mean we're definitely headed for a flip? Not necessarily. The magnetic field has weakened and recovered before without reversing.
It's done this dance many times. But combined with the sprinting North Pole, the growing South Atlantic anomaly, and the historical pattern showing we're overdue for a reversal, a lot of scientists are paying very close attention. Computer models of Earth's core suggest that the conditions inside our planet right now do resemble conditions that preceded past reversals. The flow patterns of that liquid iron ocean deep below are shifting in ways that could potentially trigger a flip. But here's the frustrating part. We can't predict it with any certainty. We're essentially watching a planetary scale process that operates on timescales so long that all of human civilization is just a blip. The poles could flip in the next 1,000 years, or they might not flip for another 100,000 years. We simply don't have enough data to know. What we do know is that when it happens, whenever that is, the consequences will be global. So what actually happens when the poles flip? What would we experience, and should we be worried?